at satellite imagery and they realize, oh my God, that's the caldera of a volcano, like this Yellowstone thing. We thought it was just this crazy place with hot springs. Like, no, that's a super volcano that is a continent killer.
Recent alert from the Yellowstone monitoring system has sent ripples of anticipation through the scientific community. Renowned podcast host Joe Rogan has also recently shed light on the massive dome-shaped uplift in the park that is increasing in size. But is the Yellowstone sleeping giant showing signs of awakening? And if so, what could be the consequences? How prepared could we be to contain damages?
We end here tonight with a sleeping giant, an ancient super volcano beneath Yellowstone National Park. It has been snoring for thousands of years, exhaling through the park's famous geysers. As Jamie Yukas reports, recent eruptions have some wondering if the giant is awakening.
Join us as we discover the facts behind the Yellowstone system alert that just announced that the dome-shaped uplift is increasing. The American West Yellowstone National Park. A growing giant underneath the American West Yellowstone National Park is a marvel of nature's beauty. It also sits at the top of a ticking geological time bomb, which is the Yellowstone supervolcano. This supervolcano is a colossal force of nature, with the potential to unleash devastation on a scale. We can hardly comprehend the history, as Yellowstone's volcanic activity is both fascinating and a bit terrifying. The area has witnessed massive eruptions, the likes of which are hard to imagine. And now, according to Joe Rogan, the huge dome-shaped uplift is increasing in size and worrying scientists. The Huckleberry Ridge eruption set a precedent for the immense volcanic activity that defines Yellowstone's geologic history. This eruption, one of the largest in the Earth's recent history, formed the initial Yellowstone caldera, a massive volcanic crater that remains a central feature of the park today. Following this colossal event, the area witnessed two more significant eruptions: the Mesa Falls eruption around 1.3 million years ago and the Lava Creek eruption approximately 640,000 years ago. Each of these eruptions contributed to the complex volcanic landscape of Yellowstone, shaping the region's topography. The Mesa Falls eruption, while smaller than the Huckleberry Ridge event, was still of monumental scale. It produced widespread ashfall that covered large areas of the current United States, further transforming the landscape and impacting the environment. The opening formed by this eruption partially overlaps with the earlier Huckleberry Ridge opening, illustrating the ongoing volcanic activity beneath Yellowstone. The most recent of the three, the Lava Creek eruption, was responsible for the formation of the present-day Yellowstone caldera, the park's largest and most notable volcanic feature. This eruption was so vast that it ejected a massive volume of volcanic material with ash reaching as far as the Mississippi River and the Gulf of Mexico. The aftermath of this eruption saw the creation of the opening that spans almost the entire width of the park. These eruptions have had huge effects on the global climate, influencing weather patterns and leading to cooler temperatures worldwide, the ash and gases released into the atmosphere. These features comes from the still active magma chamber beneath the park, a direct link to the volcanic eruptions that shaped Yellowstone landscape millions of years ago. Today, the evidence of these ancient volcano eruptions provides invaluable insights into volcanic processes and the Earth's geologic history. The layers of volcanic rock and ash deposited by these eruptions serve as a geological record, allowing scientists to piece together the timeline of volcanic activity in the region. This record is important for understanding Yellowstone's past and also for predicting future volcanic behavior and assessing the potential risks associated with the park's supervolcano. As such, the study of these eruptions and their aftermath continues to be a crucial aspect of geological research in Yellowstone. At the heart of the volcanic activity occurring today is the Sour Creek Dome and the Mallard Lake Dome. These domes are not your typical volcanic structures. They're more like giant blisters on the Earth's surface, formed by the upward pressure of magma refilling the opening's magma chamber. To understand the significance of these domes, imagine a giant underground balloon filling up with magma. As this balloon expands, it pushes the ground above it upwards, creating a dome shape. This is essentially what's happening beneath the Sour Creek and Marred Lake areas. These domes are massive, stretching over several kilometers in width and rising, hundreds of above the opening floor, and recently something strange is happening to these that scientists have noticed. The presence of these resurgent domes is a clear sign that the volcanic system beneath Yellowstone is far from dormant. In fact, it's an indication that beneath the park, serene lakes and majestic geysers, lies a restless giant biding its time. The increasing size of the dome-shaped uplift, as recently announced, serves as a reminder of the dynamic and potential dangerous nature of this supervolcano. The Yellowstone supervolcano is a sleeping giant with a history of cataclysmic eruptions that have reshaped the landscape and affected global climate. The formation of the Yellowstone caldera and the resurgent domes like the Sow Creek Dome and the Marred Lake Dome are proof of the ongoing volcanic activity beneath the park. Understanding these geological features is crucial as they offer clues about the behavior of the supervolcano and the potential risk. It poses recent observations and warnings. However, in recent times, Yellowstone National Park has been the center of heightened attention due to a series of unsettling signs pointing towards increased geological activity among these. The most notable is the significant increase in the size of a dome-shaped uplift within the park. This is a massive alteration in the park's very foundation, suggesting that the forces beneath Yellowstone are stirring. Adding to the concern are the mysterious shifts in the water levels of Yellowstone Lake. Scientists have observed that the lake's water isn't as stable as it once seemed. There has been no reduction in the water levels of Yellow Park. Instead, it's been tilting like a seesaw, indicating something powerful and dynamic is happening beneath the surface. This tilting of the lake is a red flag, signaling changes in the volcanic system below. Furthermore, the appearance of long fissures in the ground has led to widespread speculation and concern. These fissures are potential indicators of magma movement beneath the park's surface. The presence of these fissures suggests that the volcanic activity underneath Yellowstone is a very real and present danger. The recent observations in Yellowstone, from the growing dome-shaped uplift to the shifting water levels and emerging fissures, are clear indicators of increased volcanic activity. These signs have played a crucial role in raising public awareness about the potential dangers of Yellowstone, the science behind the activity. But what causes these reactions under the earth? What are the chances of these dangers happening now? Join us, we dive deeper. Underground activities and natural phenomenon. Yellowstone National Park is a living laboratory where the Earth's inner workings are on full display. Central to Yellowstone's geological mystery are the resurgent domes, particularly the Sour Creek Dome and the Marred Lake Dome. The importance of these domes extends beyond their physical presence. They are key indicators of the restless nature of the volcanic system underneath Yellowstone. The movement and growth of these domes provide critical clues about the behavior of the magma chamber and the potential for future volcanic activity. Monitoring such a dynamic and complex system requires advanced technology, and scientists have made significant strides in this area. Modern techniques like global positioning system and interferometric synthetic aperture radar are at the forefront of these efforts. The global position system is used to precisely measure ground movements, allowing scientists to track the slightest shifts that could indicate volcanic activity. Interferometric synthetic aperture radar complements this by using radar images from satellites to map ground deformation over large areas. These technologies have revolutionized our ability to monitor volcanic activity, providing detailed and continuous data that was previously unattainable. Recent scientific findings have shown the importance of this advanced monitoring. The discovery of the increasing size of the dome-shaped uplift is a case in point. This significant change hints at the movement of magma beneath the surface and could signal an increase in volcanic activity. Similarly, the Hidden Falls Fissure, a massive crack that appeared seemingly overnight, has captured the attention of both scientists and the public. These discoveries highlight the dynamic nature of Yellowstone's geology and show the need for ongoing vigilance. The implications of these findings are huge. The advances in monitoring technology have provided us with unprecedented insights into these processes, allowing scientists to track the park's volcanic activity with remarkable precision. Potential consequences of an eruption. But why are scientists so terrified of Yellowstone erupting? The potential eruption of the Yellowstone supervolcano is a scenario that carries with it catastrophic consequences for the immediate vicinity and potentially for the entire globe. One of the most immediate effects of such an eruption would be the widespread fallout of volcanic ash. This ash, much like fine, abrasive sand, would blanket landscapes, smothering everything in its path. This fallout could disrupt transportation networks, burying roads, railways, and airports and bringing travel to a standstill. But the impact of ash extends far beyond mere inconvenience. Fallout could disrupt transportations. The weight of accumulated ash could cause buildings to collapse, power supplies to be disrupted, and lead to significant structural damage. Furthermore, this ash loaded with sharp particles poses a serious threat to respiratory health, capable of causing severe problems if inhaled by humans or animals. The environmental damage would be massive. Ash and volcanic gases can lead to the contamination of water sources, making them unsafe to drink and harming aquatic ecosystems. The sulfur dioxide gas released during the eruption could mix with water vapor in the atmosphere, falling back to Earth as acid rain. This acid rain would devastate ecosystems, acidifying lakes and rivers, damaging plant life and corroding built structures beyond the environmental impact. A Yellowstone eruption could usher in a volcanic winter. The massive amounts of ash and gases ejected into the atmosphere would form a dense cloud, blocking sunlight and leading to a significant drop in global temperatures. This sudden cooling could have dire consequences for agriculture, leading to widespread crop failures and food shortages in a world heavily reliant on stable agricultural outputs. This could result in a global food crisis, with shortages leading to increased prices and potential famine in more vulnerable regions. The societal impacts of such an eruption would be far-reaching infrastructure damage from ash fallout and seismic activity. The health hazards posed by ash and volcanic gases could lead to increased strain on medical services, with respiratory issues and other health problems becoming more prevalent. Joe Rogan's expose. Joe Rogan has an interesting view about the recent incident in Yellowstone. Joe Rogan, a renowned commentator and all-round enthusiast, has a knack for delving into complex issues and bringing them to the forefront of public discourse. His discussions on the Yellowstone supervolcano are no exception. Rogan has raised strong warnings about the potential dangers hidden beneath the serene landscapes of Yellowstone National Park, capturing the attention of his vast audience and amplifying the conversation around this geological giant. Rogan highlighted the sheer power of the supervolcano and the massive impact its eruption could have on the surrounding region and potentially on a global scale. Through his platform, Rogan has succeeded in painting a vivid picture of the supervolcano's might, drawing from the well of scientific findings to underscore the seriousness of the situation. One of the key aspects of Rogan's commentary is how it intersects with scientific findings. While he is not a scientist, Rogan often references the latest research and expert opinions to inform his discussions. This approach has allowed him to bridge the gap between the scientific community and the general public, translating complex geological phenomena into terms that are easy to understand and engaging to his audience. Rogan's discussions about the recent unsettling signs at Yellowstone, such as the increasing size of the dome-shaped uplift and the appearance of fissures, echo the concerns raised by scientists monitoring, research, and prepared. But how exactly do scientists know that this volcano is about to explode? The task of keeping a vigilant eye on the Yellowstone. According to Joe Rogan, supervolcano involves a complex network of monitoring efforts crucial for deciphering the subtleties of this massive volcanic system. Scientists and researchers are engaged in continuous observation, employing a range of advanced technologies to track any changes that might indicate shifts in volcanic activity. This diligent work is foundational in understanding the supervolcano's behavior, providing invaluable data that inform both the scientific community and the public. Central to these monitoring efforts are cutting-edge tools like GPS and INSAR. Beyond mere observation, scientific research plays a pivotal role in disaster preparedness. Understanding the supervolcano's intricate mechanisms allows researchers to develop potential strategies for mitigating the impacts of a possible eruption. This research is about predicting when an eruption might occur, and about understanding how such an event would unfold and the best ways to protect lives and infrastructure. For instance, the study of past eruptions and the behavior of resurgent domes within the opening provides insights into the supervolcano's eruptive history and potential future activity. This knowledge is instrumental in developing evacuation plans, designing infrastructure that can withstand volcanic events, and implementing early warning systems to alert the public in a timely manner. Moreover, the ongoing research contributes to the broader field of volcanology, enhancing our understanding of volcanic processes and their impacts on the environment and human society. This body of knowledge is crucial for informing policy decisions, emergency response strategies, and public education campaigns aimed at increasing awareness and preparedness among communities at risk. The monitoring and research efforts centered around the Yellowstone supervolcano are vital components of a broader strategy aimed at safeguarding lives and minimizing the potential damage from volcanic events through continuous observation, detailed scientific research, and the development of preparedness strategies. We can better equip ourselves to face the challenges posed by one of nature's most formidable forces, Yellowstone's natural marvels. Yellowstone National Park is not just home to the ominous supervolcano lurking beneath its surface. This park has many natural phenomena, each more fascinating than the last showcasing. The Earth's dynamic processes, from the geothermal wonders to the rich biodiversity, Yellowstone offers a unique glimpse into the natural world's complexity and beauty. Glimpse into the beauty of the natural world. Yellowstone stands atop one of the world's largest active volcanic systems, and this geologic hotspot fuels an array of geothermal features, unparalleled anywhere else. On the globe, the park boasts over 10,000 hydrothermal sites, including more than 500 geysers, Old Faithful. The most famous geyser is proof of the park's volatile underbelly, shooting boiling water up to 180 feet into the air at regular intervals. But Old Faithful is just the beginning. The park is dotted with colorful hot springs, mud pots, and ferals, each contributing to the eerie beauty of this volcanic wonderland land. The Grand Prismatic Spring, known for its striking colors, ranging from blue to orange, is the largest hot spring in the United States, and a visual spectacle resulting from microbial mats around its edges. But that's not all. The Grand Canyon of the Yellowstone, another breathtaking feature, showcases the park's dramatic geological history carved by the Yellowstone River over thousands of years. This canyon stretches approximately 24 meters long, up to 1,200 feet deep, and more than 4,000 feet wide. In places, the canyon's walls display a tapestry of colors. Thanks to the hydrothermal alterations of the rolly rock, the lower and upper Yellowstone Falls add to the canyon's majesty, creating spectacular waterfalls that plunge into the Yellowstone River, further sculpting the landscape. Yellowstone's natural phenomena extend beyond its geothermal and geological features. The park is a sanctuary for a wide range of wildlife, making it one of the last intact natural ecosystems in the northern temperate zone. It's home to large, free-roaming herds of bison, often considered a symbol of the American West. Visitors might also spot elk, grizzly bears, wolves, and bald eagles, each playing a crucial role in the park's ecological balance. This rich biodiversity offers invaluable insights into conservation, the interdependence of species, and the complexities of natural habitats. The park's flora is as diverse as its fauna, with over 1,700 species of trees, shrubs, and wild flowers, painting the landscape in a mosaic of greens, yellows, and purples. The vast expanses of lodgepole pine forests, interspersed with aspen, spruce, and fir, provide a contrast to the park's geothermal areas. The forest, on the other hand, provide a contrast to the park. These forests not only offer a habitat for wildlife, but also play a significant role in the park's ecological processes, including fire regeneration cycle that shape the landscape. Natural forest fires are a critical aspect of Yellowstone's ecology, clearing old growth and making way for new life. The 1988 fires, one of the largest in the park's history, transformed over a third of Yellowstone, initially perceived as a catastrophe. However, the aftermath revealed the resilience and adaptability of nature, with new growth flourishing in the burned areas, demonstrating the role of fire in ecological succession and forest renewal. Volcanic eruptions are among the most powerful natural events on Earth. with the ability to reshape landscapes, affect global climates, and dramatically impact human and ecological systems throughout history. Several eruptions around the world have demonstrated the immense force and far-reaching consequences of volcanic activity, consequences of volcanic eruptions. But have there been real-life instances of volcanic eruptions and their devastating consequences? The eruption of Mount Tambora. The eruption of Mount Tambora in 1815 stands as one of the most powerful eruptions in recorded history. The explosion was so huge that it ejected approximately 100 cubic kilom of magma ash and volcanic gases into the atmosphere, creating a global climatic phenomenon known as the Year Without a Summer. The Mount Tambora eruption in 1815 led to the Year Without a Summer and had huge socio-economic effects that rippled across the globe. The ash and sulfur dioxide that were thrust into the stratosphere reflected sunlight away from the Earth, leading to abnormal weather patterns that persisted for years. In Europe, the summer of 1816 was marked by incessant rain that caused devastating floods, ruining crops and leading to one of the worst famines of the 19th century in North America. Particularly in the northeastern United States and eastern Canada, snow fell in June and frost was recorded in July, decimating harvests and exacerbating food shortages. The effects of the eruption were not limited to the northern hemisphere in the tropics. The monsoon cycle was disrupted, leading to abnormal rainfall patterns that contributed to outbreaks of cholera in India and famine in China. The global temperature anomalies induced by the eruption also affected ecosystems, leading to the migration of species to new areas and the disruption of natural predator-prey relationships. Culturally, the dramatic climate changes inspired notable art and literature. For example, the gloomy cold summer of 186 is believed to have influenced Mary Shelley's creation of Frankenstein and Lord Byrobe 'neath the surface of Yellowstone National Park. A concerning change is happening, and scientists have recently announced it. Moreover, the Tambora eruption serves as a critical case study for understanding the potential impacts of volcanic-induced climate change. It provides valuable insights into the short-term climatic consequences of large-scale volcanic eruptions, helping scientists to refine models that predict the Earth's climate response to aerosol injections into the atmosphere, whether from volcanic activity or hypothetical geoengineering efforts. The eruption of Katoa. The 1883 eruption of Katoa had immediate catastrophic impacts and also left a lasting imprint on the world in EU's unexpected ways. The sheer force of the eruption was equivalent to 200 megatons of TNT, about 13,000 times the nuclear yield of the bomb dropped on Hiroshima. The sound of the explosion was so loud. It was recorded as the farthest traveled sound in history, heard as far away as the island of Rodriguez near Machias. Approximately 4,800 kilometers away, the tsunamis generated by the eruption were equally unparalleled, with waves reaching heights of up to 40 m, obliterating coastal, villages, and towns. The sea waves traveled across the Indian Ocean, affecting shores as far away as South Africa. The human toll was staggering, with most casualties resulting from these tsunamis. The atmospheric effects of the Katoa eruption were also huge and long-lasting. The ash and sulfur dioxide propelled into the stratosphere spread around the globe, creating a veil that dimmed sunlight and produced vivid red and orange sunsets, famously captured in Edvard Munch's painting. The scream, this global atmospheric phenomenon, known as volcanic winter, led to lower temperatures worldwide with an estimated decrease of 1.2 degrees Celsius the following year. 1884 saw unseasonably cold weather crop failures and food shortages in many parts of the world, demonstrating the far-reaching climatic impacts of significant volcanic eruptions. The Katoa eruption also marked a significant moment in the field of volcanology and the study of atmospheric sciences. It was one of the first major eruptions to be systematically studied from a scientific perspective, leading to the establishment of the Volcanological Survey of Indonesia. The global dispersion of ash and the atmospheric effects were meticulously recorded, providing valuable data that contributed to the development of modern climatology. The eruption emphasizes on the importance of global telecommunication networks, as it was among the first worldwide news events to be rapidly communicated across the telegraph network, highlighting the interconnectedness of the world in the face of natural disasters. The eruption of Mount St. Helens. The 1980 eruption of Mount St. Helens was a multifaceted disaster that extended well beyond the immediate explosive event. The blast was followed by a massive pyroclastic flow, a high-speed avalanche of hot ash, volcanic gas, and debris, which scorched and flattened everything in its path for miles. This flow was accompanied by volcanic mud flows that buried river valleys and damaged bridges, roads, and buildings, complicating rescue and recovery efforts. In addition to the human tragedy and infrastructural damage, the ecological consequences of the eruption were huge. Approximately 230 square miles of forest were devastated, transforming lush woodland into a barren and wasteland. The intense heat from the eruption and the subsequent pyroclastic flows sterilized the soil. Initially, making the area seem lifeless, however, this destruction set the stage for an extensive natural experiment in ecological succession in the years following the eruption. Scientists closely monitored the gradual return of plant and animal life to the blast zone, providing invaluable insights into how ecosystems recover from catastrophic disturbances. The eruption also led to significant advancements in volcanic monitoring and emergency preparedness before the 1980 eruption. Mount St. Helens had been dormant for 123 years, and its reawakening highlighted the need for better predictive capabilities in response. The United States Geological Survey intensified its monitoring of the nation's volcanoes, particularly those in the Cascade Range, employing new technologies and methodologies to detect signs of volcanic activity. Early, one of the most critical lessons learned from Mount St. Helens was the importance of paying attention to warning signs in the months leading up to the eruption. The mountain exhibited numerous precursors, including earthquakes, steam explosions, and the growth of a massive bulge on its north flank. These signs prompted the authorities to establish a red zone around the volcano, a decision that undoubtedly saved lives despite the challenges in enforcing evacuations and restricting access to the area. The eruption of Mount Pinatubo in 1991. The eruption of Mount Pinatubo in 1991 was the second largest terrestrial eruption of the 20th century. The eruption produced a massive ash column and ejected a significant amount of sulfur dioxide into the stratosphere, forming a global sulfuric acid haze. This led to a decrease in global temperatures by about 0.5 degrees C over the following years. The eruption caused hundreds of deaths, primarily due to the collapse of roofs under the weight of accumulated wet ash, and left thousands homeless. The eruption of Mount Pinatubo remains a turning point in the field of volcanology and disaster preparedness due to both the scale of the eruption and the extensive efforts made to mitigate its impacts prior to the eruption. An unprecedented evacuation effort was undertaken. Scientists from the Philippine Institute of Volcanology and Seismology and the United States Geological Survey detected warning signs, such as seismic activities and gas emissions, that an eruption was imminent. This collaboration led to the timely evacuation of tens of thousands of people from the areas surrounding Pinatubo, undoubtedly saving many lives. In addition to the immediate human and infrastructural impacts, the eruption had significant environmental consequences. The ash fallout affected vast areas, damaging agriculture and contaminating water supplies, which worsened the humanitarian crisis. In addition to the immediate human, and the eruption also left a large opening at the summit of Mount Pinatubo, fundamentally altering the mountain's landscape. One of the most enduring legacies of Pino's eruption was its impact on the Earth's atmosphere. The sulfur dioxide ejected into the stratosphere reacted with water vapor to form a sulfuric acid mist that spread around the globe, creating a veil that reflected sunlight and cooled the Earth's surface. This atmospheric phenomenon provided a real-world case study for scientists, studying the potential effects of aerosols on climate, contributing valuable data to the field of climatology. Furthermore, the eruption gave rise to advancements in the monitoring and prediction of volcanic activity worldwide. The successful forecasting and evacuation operations demonstrated the value of scientific monitoring and international collaboration in reducing the human toll of volcanic eruptions. In the aftermath, there was increased investment in volcanic research and monitoring, including the establishment of more sophisticated early warning systems and the deployment of new technologies for detecting signs of volcanic unrest. These examples illustrate the diverse impacts of volcanic eruptions, from local devastation and loss of life to global climatic changes. Each event illustrates the Earth's dynamic nature and the need for ongoing research, monitoring, and preparedness to mitigate the risks associated with volcanic activity. The study of past eruptions, along with continuous monitoring of active volcanoes, is crucial for predicting future eruptions and implementing effective disaster response strategies to protect communities and ecosystems in volcanic regions. As for Yellowstone's future, it remains to be seen if the dome-shaped uplift increasing in size is just a natural phenomenon or something far more dangerous. Having journeyed through the depths of Yellowstone's volcanic heart, it's clear that vigilance, research, and preparedness are our best tools against nature's unpredictable actions. Thank you for watching. Check out another interesting video by clicking on the link appearing on your screen right now. See you on the other side.